Hello and welcome to this second video on metals, and we're looking today at the reactions of metals. Now first of all, I want to introduce the idea of reactivity. Now some metals are highly reactive. That means when they react violently, vigorously, rapidly. And these are things like potassium, sodium, lithium. These are all highly reactive metals. You don't have to do very much with them to make them react with things. They will just react. At the other end of the scale, you've got highly unreactive metals. Things like platinum, gold, silver. These are highly unreactive. That's why, for example, you can bury gold in the ground, come back years later and find it's still shiny because it doesn't react with stuff. And in the middle, you've got the other metals, right? Now, that's not all the metals, it's just a representative sample. Now, these metals have different reactivity, and we could organise them in order of how reactive they are. In fact, that's what I've done. As we go up that list, the metals are getting more and more reactive. I've written these as what we call a reactivity series. Now, we're going to be using this idea of reactivity when we look at three reactions of metals, the first of which is the reaction with water. Okay, there's our list of metals in order of reactivity. Let's imagine we've got a beaker of water, there it is, and we put in a highly reactive metal, say for example potassium. Now when potassium reacts with the water, it produces a whole bunch of bubbles. Those bubbles are bubbles of hydrogen gas, and they tend to hold the potassium up on the surface of the water there as it reacts. In fact, potassium is so reactive, it will often burst into flames. And that's the reaction finished. So what happened there? Well, this is only going to work really for the most reactive metals. Okay, you might get some reaction with calcium, you might get a few bubbles with magnesium. But for the rest, forget it. These will not react with water, so we're talking about these metals here reacting with water. And when they do, they form a metal hydroxide and hydrogen. You may remember, by the way, that hydroxides are alkalis. So, for example, when sodium reacts with water, you get sodium hydroxide and hydrogen. And there's the formulas there. But this equation is not balanced. Look, you've got two hydrogens here, you've got one there, that's three hydrogens on the right, and only two there on the left. So we're going to have to balance that up. Now what I'm going to do, I'm going to put a 2 there. That'll give me 4 hydrogens now on the left. I only need one more on the right, so if I put a 2 there, that'll give me 2 hydrogens in the sodium hydroxide, 2 hydrogens in the hydrogen, that's 4. And all I've got to worry about now is the number of sodiums. I'm going to make that 2. And that's now a balanced equation. Okay, let's move on to the reaction with acids. Okay, again, same sort of setup. You get a beaker of acid this time. Pop in a metal, and again, you get lots and lots of bubbles. And once again, these are bubbles of hydrogen gas. Eventually, the metal is used up, and the reaction's over. Okay. Now, with this one, metals are always more reactive with acids than they are with water. So you really don't want to be putting those top 3 metals there into acid. That reaction is likely to be explosive, so we won't do that. Metals less reactive than tin in this list also won't react. So for this reaction, we are talking about metals in the middle of the table. And in this case, when a metal reacts with acid, you get a salt and hydrogen. Now the salt you get will depend on which acid you use. With hydrochloric acid you get chlorides, with sulfuric acid you get sulfates, with nitric acid you get nitrates. Let's look at a couple of examples to show how that works. Suppose you react zinc with hydrochloric acid. Hydrochloric acid gives you chlorides, so you get zinc chloride. Okay? Or suppose you react calcium with nitric acid. Calcium, nitric acid gives you nitrates, so that's going to give you calcium nitrate. Okay, so how do we write this down as equations? To do this, you're going to need to know the formulas for acids. And there they are. Best thing you can do this is learn them. Okay? You can in fact work them out, and I'll give you some hint as to how in a moment, but you're best just learning them. Also, the formulas for the second bit of the acid there, chloride, sulfate and nitrate. Notice, by the way, that in the acids, they all contain hydrogens, and the number of hydrogens is the same as the valency of the other bit in the formula. So, for example, the valency of sulfate is 2, and you have 2 hydrogens in sulfuric acid. Okay, let's run through an equation. If you react magnesium with nitric acid, you get hydrogen, because you get hydrogen with all these reactions between metals and acids. But what salt do you get? Well, magnesium and nitric acid are going to give you magnesium nitrate. Okay, so this is a formula. Mg is a formula. That's the formula for magnesium. Okay, notice just Mg by itself, it's not diatomic, doesn't end in gen or ene. Nitric acid, well, that's in the table at the top there, HNO3. Hydrogen, well, hydrogen is diatomic, it ends in gen. So, all we've got to do is work out the formula for magnesium nitrate. So there's magnesium. What about nitrate? Well, there it is in the table at the top, it's NO3. Now, the valency of magnesium is 2. It's in group 2 of the periodic table, its valency is 2. Valency of nitrate, well, that's in the table at the top, that's 1. You can't cancel down 2 and 1, so we're going to leave these as they are and cross them over. We don't bother writing 1s. But that 2 there, what does it actually mean? It doesn't mean, for example, that there are 6 oxygens, or at least not just 6 oxygens, and certainly doesn't mean that that should be 32. What it means is you've got 2 nitrates, 2 NO3s, so 2 of all of that. So we put that into brackets like that. Now we've got a problem. I've just said you've got 2 nitrates there, but there's only 1 over here. Not only that, I've got 2 hydrogens here, and only 1 over here. So I'm going to have to balance this, but fortunately that's an easy fix. Just put 2 there. Okay, and that's now balanced. Check it if you like. Finally, the reaction with oxygen. Now, in some ways this is simpler. It's a fairly straightforward reaction. Now, all these metals will in fact react with oxygen. It's just a matter of how easily. Potassium reacts with oxygen really easily. Gold really only if you provide it with lots and lots of oxygen and make it really hot. So, how can we do that? How can we react a metal with lots of oxygen? Right, let's take a test tube. And into there, I'm going to put a chemical called potassium permanganate. Don't sweat too much about remembering potassium permanganate, because what its job is to make oxygen. When we heat this, it makes oxygen, so that the metals react with oxygen. Now we want to hold that in place, so we'll put in a substance called ceramic wool. That's just a substance that will let the oxygen through without catching fire. Now we'll put in a metal and some more ceramic wool. Now I've coloured that brown because I want you to imagine that metal is copper. Right, we mount that in a clamp and stand and we heat the bottom end of it. So when we heat that, it generates oxygen. The oxygen will pass over the hot metal. And when it does, You get a dull red glow passing through the copper. Nothing very exciting, just a dull red glow. And when that fades, you'll find you've got black copper oxide. Now, as you repeat that with more and more reactive metals, what you find is that the glow from the metal gets brighter. That's what tells us the metal's more reactive, a brighter glow. Until when you get to magnesium, you get a really bright light before it fades to leave you with white magnesium oxide. Now, these metals are in order of increasing reactivity. So, as you go up there, the glow gets brighter to the point when you get to the top, potassium, sodium and lithium. I really wouldn't do that experiment with those three metals, certainly not with the level of insurance I've got. Okay, so what's going on here? Very simple. The metal is reacting with the oxygen to make the metal oxide. That's dead easy. So here's an example. Aluminium plus oxygen gives you aluminium oxide. Now, I've chosen those to make this a little trickier. But let's work it out. Aluminium, that's just Al. Not diatomic, doesn't end in gen or ene. Oxygen does end in gen, it's diatomic. Aluminium oxide. Okay, well there's aluminium and oxygen. Aluminium is in group 3 of the periodic table. Its valency is 3. Oxygen is in group 6 of the periodic table. Its valency is 2. Again, we can't cancel 3 and 2 down, so we just cross them over. That then is the formula for aluminium oxide. Once again though, it's not balanced. We've got a 3 here, 3 oxygens, and only 2 over there. Now, a little trick of the trade here. When you've got a 2 and a 3, it's worthwhile remembering that 6 divides equally by 2 and 3. So we can get both 3 and 2 up to 6 by putting the right numbers at the front. There and there. So if I put a 2 in front of the Al2O3, that'll give me 2 times 3 is 6 oxygens. If I put a 3 in front of the O2, that will give me 3 times 2 is 6 oxygens. So the oxygens now balance. All I've got to worry about now is the aluminiums. I've got 2 lots of 2 aluminiums on the right, so I want to put a 4 here. And that's now balanced. Okay, so summing up. Metals can be arranged in a reactivity series. Some metals are highly reactive, some are highly unreactive, but most are somewhere in the middle. Some metals react with water, and those metals that do produce the metal hydroxide, which of course is an alkali, and hydrogen gas. But this only works for the most reactive metals. This, by the way, is why sodium, lithium and potassium are called alkali metals. When they react with water, they produce an alkali. Okay, most metals react with acids, and when they do, they produce a salt and hydrogen. But this only works for metals more reactive than copper. In a later video, we'll find out why. Finally, you've got the reaction with oxygen, which produces the metal oxide. Now, we've got through quite a lot there. It's probably a good idea to go back through this video, pausing it after each reaction, thinking it through, and going away and doing some practice. But that's all from me just now. Bye now.